Alrighty, acids and bases. So acids contribute a H ion, so a hydrogen ion to the solution, and they have a pH of less than 7. So these are all considered acidic. And some examples, most of your fruit juices are acidic. This says gastric acid, that's the same thing as stomach acid. Coffee is usually a little acidic. Milk, depending on what you get, like what kind, can be basic, but it can also be acidic. Here are some, okay, so bases. Bases donate an OH, a hydroxide ion. Yes, that's a polyatomic ion. And then they have a pH between 17 and 14. And most of your like household cleaners, soap, bleach, detergent, stuff like that, those are all basic. And then you can see right here in the middle, water is neutral, pure water. That's because when water dissociates, it becomes a positive ion and a negative ion, and it's the hydrogen ion and the hydroxide ion. So because of that, remember, this is the acid and this is the base. So it has one acid, one base. That makes a neutral solution. When you add something to water that doesn't make an H ion or an OH ion, then it stays neutral. So something like salt water is still neutral because salt doesn't add the H or the OH. These are just some interesting known pHs. So blood is slightly basic. Rainwater is slightly acidic. That's because of the carbon dioxide in the air. So places that have a lot of factories and stuff tend to have more like acidic rain. Fish can tolerate all the way from 5 to 9, so they can tolerate a pretty large range of pH. And remember, 7 is neutral, so they can tolerate acidic water and basic water. And then Snake River is the one you read about in that fish kill thing, and so obviously the fish didn't die because their water pH, since that's livable for fish. So when molecules have a positive and a negative, so water has the H and the OH, we call that polar. Because it has a negative charge and a positive charge. And they can be split up, right? They're split up into their ions. Something like carbon dioxide looks like this. So there's a positive here and a negative on each of my oxygens. I can't like split this anyway to get my negatives on one side and my positives on the other. So therefore my like positives and negatives are all together. So this is non-polar. But because here my like H, this is negative and this is positive, I can split that and I can get a polar molecule. So here where it says all ionic compounds are, or will dissolve in water, all polar compounds, this is the like dissolves like rule. So if I'm polar, I can dissolve in a polar substance like water. If I'm non-polar, I can dissolve in a non-polar substance like hexane. So this, and remember all ionic molecules are polar, and then ionic is a metal plus a non-metal. We learned that in the other notes. So metal plus a non-metal. So here sodium is metal, chlorine is non-metal, so it's ionic, so it can dissolve in water. Here magnesium is metal, and then OH, that's a polyatomic ion. It can also dissolve in water because it's polar. This will give me a neutral solution. This will give me a basic solution because it has the OH. This doesn't have an H or an OH, so it stays neutral, but this one has an OH, therefore it becomes a basic solution. That's it. If you guys have any questions, please let me know.